SSL pinning bypass. Let's begin with an introduction to SSL pinning. SSL pinning is a security technique implemented in mobile apps to verify the identity of a server to where it is communicating. It allows mobile apps and other client software to verify a server's identity by comparing the server's SSL or TLS certificate or a public key with a trusted value embedded in the client application. This helps to prevent man-in-the-middle attacks where an attacker intercepts the communication between the client and the server and tries to impersonate the server using a fake certificate. Moving on to bypassing SSL pinning. In order to bypass SSL pinning, the device must be rooted. SSL pinning bypass can be performed using a special script within the JavaScript available from the following link. The script bypasses SSL checks by hijacking the methods and custom built-in libraries in end-user applications for validating certificates and allowing it to always return true. So by creating the self-signed certificate from verb suite, we can actually fool the end-user app into installing a trusted CA by compromising the SSL session using Frida. Practical. In the demonstration video, we will show how we can bypass and perform a successful MITM attack using an SSL pinning attack with the Androgoat application and the Frida tool. Now first, open your verb suite, go to Options, click on Import Export CA Certificate, choose Certificate in DER format, click on Next, click on Select File and type ca.crt in the file name field and hit Save. Now open your browser and search for the Frida server. Click on the first link. Scroll down and click Show all 261 assets. Scroll down to look for the Frida server as mentioned here and click on it to download it. Open a new tab and search for SSL pinning bypass script. Open the first link, select and copy the whole script. Go back to the downloads folder, type CND on the navigation field to open a command line tool. Type notepad SSL bypass.js and hit enter. Paste the copied script and press Ctrl S to save the file. Unzip the downloaded Frida file. Go back to the command line and now type the following command into the emulator. Type adb shell and enter to get into the shell in the attached emulator. Now type cd data local temp, hit enter. Again type the following command and hit enter to start the Frida server in the background. Now to check if the Frida server is running in the background, type ps and hit enter. You can see that the Frida server is up and running. Open another command line terminal, type and enter cd downloads. Now type the following command to inject the SSL bypass script to the Android application. Now open your emulator, click on network intercepting and click certificate pinning to check if SSL pinning is successful. From the command line, we can see that SSL pinning was successful as we can see that the text displayed SSL connect text initialized with our custom trust manager. Let's now discuss what measures can be taken to mitigate SSL pinning bypass. Implement anti-tampering measures such as code integrity checks and runtime protection mechanisms to detect and prevent attempts to modify the client application. Regularly update the pinned value. Reduce the risk of attackers using a stale or compromised SSL TLS certificate to bypass the SSL pinning. Implement certificate pinning validation. Implement certificate pinning validation checks to verify that the SSL TLS certificate presented by the server matches the pinned value. Monitor for suspicious activity. Implement logging and monitoring to actually detect and alert suspicious activity such as SSL TLS certificate changes or unexpected SSL TLS communication patterns. Perform a root check on the device. It is essential to check whether the device has been rooted. As we have seen in our previous demonstration video that the rooted device can play a significant role in bypassing SSL pinning.